Hi girls, so good morning. What we're going to do today is have a quick go at revising fuels and heats. And fuels and heats really, well, first of all, it comes up in question 6 on your paper. And it sort of divides into two sections. There's the whole section about petrol and fuel, which is a lot of vocabulary. And then there's a second section, which is a kind of a slightly more mathsy bit where we use Hess's law. So what we're going to do first is we're going to kind of review a lot of the vocabulary that we use in this section. To do that, really, rather than going through a particular question, we're just going to do a mind map. Okay, so we're going to have a go of a mind map of fuels and heats. And then hopefully that will help you to be at least familiar with some of that vocabulary, and then you can go back and read about it yourself, maybe make your own mind map, and then try a couple of questions yourself. All right. So this is basically all about vocabulary, and the first vocabulary we need to know are a couple of key words which we should have learned already, which we would have learned in fifth year really, which is what a homologous series is. You should know what that is. So it's chemicals which have the same functional group but differ by CH2. Then you've got alkanes, which is the first homologous series we learned about, where we have only hydrocarbon with only single bonds between the carbons. And then isomers are groups of chemicals which have the same molecular formula but different structural formula. So they're arranged differently in space, basically. And these are kind of useful words to know when we're dealing with this topic. It's important to remember that you don't necessarily need to know all your functional groups and all the reactions for this question. That's question 8 is the organic reactions question, but nonetheless it helps if you do know your organic chemistry reasonably well. So that is worth revising for this as well. Okay. So basically what we're looking at here is two sources of fuel. The first one is crude oil and the second one is natural gas. So natural gas is something that comes out of the ground and it's more or less ready to use, to be honest. There's one thing that we add to natural gas that's really important, and that's called mercaptans. Mercaptans are a type of chemical, and what they do is they add a smell to the gas. So natural gas is very combustible, but it also doesn't smell. So if there was a leak, for example, in a town or in a house or something like that, it could cause an explosion. So they artificially add chemicals to it to give it a bit of a smell. And that's what mercaptans are. They often contain sulfur, but you need to be familiar with that word. Okay, so natural gas is more or less good to go. Crude oil, a bit more complicated, right? Because crude oil is a big mix of lots of hydrocarbons. So what happens is it has to be distilled, okay? And it's distilled in a big tower that looks a bit like this. You can see here's one I prepared earlier, right? So the crude oil goes in here like this, all right? So the crude oil is going in here. It's supposed to be an arrow. Sorry, I didn't do a very good job. And basically in here what you have is a big boiler or a heater or a furnace, okay? You can call it a furnace if you want. Can you see that? There you go. Okay? So the bottom bit is hot, and as we go up here, it gets cooler. Okay, so this is cold, and this is hot. Makes sense, doesn't it? And what happens is that the shorter chains with the lower boiling points rise to the top. The longer chains with the higher boiling points fall to the bottom. Okay, so this is fractional distillation, and we all saw this when we went on our trip to Swords there a couple of months ago. A big, huge tower that looks like this, and you can see that these pipes coming out of this tower like this. So the very, very short chains will have the lowest boiling point, and that's called LPG, or liquid petroleum gas, and that's basically really short alkanes like propane and butane. And you will have seen these maybe if you've ever gone camping, or you've seen one of those orange kind of containers that contain gas that they sell at petrol stations sometimes. That's LPG, and it's used as a fuel for particular things. Right, slightly longer than that, so that's C3 to C4, right? That's the length of the carbon chain. So slightly longer chain, C5 to C8. And now we're talking about what's often called light gasoline or petrol. Okay, in America it's called gasoline. And that's used as fuel in cars. All right, so this is the next highest fraction there, like that. The next one is called naphtha. Naphtha is kind of a similar length, maybe a little bit longer, but that's used in the chemical industry to make starting materials for lots of different types of chemical processes. So as you can see, as we go down this tower, these fractions are getting longer like this. So now we have kerosene. Okay, kerosene is next. Again, it's getting longer, and this is used in jet planes. Okay, so aircraft, you see the aircraft being refueled at the airport, whatever. Kerosene is what they use. Again, if we go longer than that, we have something called gas oil, which is starting to get really thick now. The longer the chains, remember, the thicker the liquid will be due to the greater van der Waals forces. So it's going to have a higher boiling point. And this tends to be used in sort of for ships and for fuel for homes, so home fuel and stuff like that. And then the last one is fuel oil. And fuel oil is really, really thick. And it's used to make tar, bitumen, things like that. All right, and that's the really, really longest one. And that's got it's a really long carbon chain, probably greater than 19 carbons. All right, so once we've put it through that fraction tower and we've divided it up like that, we're then able to use it. All right, but obviously some of these fractions are more useful than others. So one of the things that we look at when we're doing this is we look at something, we have to be able to measure how good these fuels are, and we use a measure for this called the octane number. And an octane number is just a way of measuring how good a fuel burns. Okay, so we want fuels to burn well, we want them to burn smoothly in cars, we don't want them kind of chuddering along. If you see any of the old clips of very old films with old cars in them, you'll sometimes hear some of the engines are kind of shuddering along. We don't really want that. We want nice smooth combustion. So we have to be able to measure that, and we use the octane number to do that. Now, octane number goes from 0 to 100. All right. You need to know the name of two chemicals, which are basically the standards for this. The octane number, the chemical that has an octane number of 0 is heptane. All right. So you should be able to draw that, and you should be able to know what it is. And the octane number that has a number of 100 is 2,2,4 trimethyl pentane. And again, you should be able to draw that and name it. They are the only two chemicals that you need to know the octane numbers of. This one is good, this one is bad. And basically all the other petrols and fuels are in between those two. And the whole point here is we want to avoid something called knocking. Knocking, or sometimes called auto-ignition, is where things explode in the engine and make it splutter, basically, and it doesn't burn smoothly. Okay, so we can now measure the fuel, and we can know whether it's very good fuel, whether it's close to 100 octane number, or whether it's not a good fuel, whether it's close to 0. And if we go back to our tower here, what you'll see is that in this tower, you've got a range of different materials. Now, when crude oil is pulled out of the earth, an awful lot of the fractions tend to be down here, right? We tend to get a lot of long chains. If you think of what crude oil looks like, it's very thick black stuff, isn't it? It doesn't really look like petrol. So there's an awful lot of this stuff in it. And this stuff isn't really very useful. It's not where the money is. The money is up here, okay? We need to be able to make lots and lots of petrol to make lots and lots of money. So it would be really useful if we could turn some of these into more useful, smoother burning fuels. And we can. And there are 3 processes that we can use to do that. And again, you need to be familiar with these. So these 3 processes are dehydrocyclization, okay, which is a bit of a mouthful. But really what that means is we're turning a chain, out of focus there, chain into a ring, okay? And it turns out that rings burn a lot better than long chains. So if you can convert a chain into a ring, you can make that fuel burn a lot better. And you do that very simply by heating it over a catalyst. Okay, you don't need to know what that catalyst is. It's not important. What's important is the name of the process, and that you can identify it if you're given an example, and that you realize that what's happening is a chain is turning into a ring. The second process that happens is called isomerization. And isomerization happens when we turn a straight chain into a branched chain. Because it turns out that alkanes that are branched burn a lot better than alkanes that are straight. And they'll burn a lot smoother, they'll have a higher octane number. So it makes sense to be able to turn some of these longer chains that don't burn as well into shorter chains. And the last process that we need to know about is called cracking. And cracking basically takes those long chains and turns them into short chains. It literally cracks them or breaks them apart into shorter chains. Now, it's a good idea to go through the exam papers and find some examples of questions that come up, because they do ask you specific chemicals and ask you to name which of these processes there is and which one is being used for particular examples, and you should be able to identify them. So that's definitely worth trying. But they are the three processes, and that in a nutshell is what they do. There are also two things that we can add to the petrol called additives, much the same way as we add things to food. And these additives do the same thing as these processes. They make the fuel easier to burn. They give it a higher octane number. And again, there are two types that you need to be familiar with. The first one is not used anymore. It's tetraethyl lead. Okay, so you might see in the petrol station that it says it's unleaded petrol. Well, now all petrol is unleaded, but that wasn't always the case. Tetraethyl lead used to be added, but it's discontinued now because it's toxic. Okay, so it's a toxic chemical. It's not used anymore. And the other thing that is added are things called oxygenates. And oxygenates are literally anything that contain oxygen. So you're familiar with some types of those already. Alcohol is one example. And another example is a type of family which you're not really familiar with. A word to remember is ether. All right, so we're nearly there. I know this is a long one. But there's one other thing that you need to be aware of, one other fuel that we use. And the fuel that we use sometimes is hydrogen. And hydrogen is considered a very clean fuel because when it burns, the only side product is water. There is no other side product. There's no carbon monoxide, there's no soot, there's nothing else. So it's really, really useful in that sense. Unfortunately, it's quite difficult to make and quite difficult to transport because it's very combustible and it's a gas and it can catch fire. But there are two processes by which we can make hydrogen. The first one is called steam reforming. And steam reforming, there's two equations you need to be familiar with, where we take methane, we heat it over steam like this. Okay, so there's the methane, there's the steam, and we get carbon monoxide and hydrogen gas, right? Hydrogen is what we want. Carbon monoxide we definitely don't want because it's toxic. So what they do is they literally pump that back into the system again and heat it again over steam. And what happens is that we get carbon dioxide and we get hydrogen like this. So there's a two-step process there. You need to be familiar with these two reactions of how hydrogen is produced by heating methane over steam like this. And the other way that we get hydrogen is a process that you are familiar with as well, called electrolysis. Electrolysis is very expensive, but it's just a way of splitting water into hydrogen. I'm running out of space here. And oxygen like that. That's supposed to be a half oxygen. That's not very good, but you get the idea. Okay, so two processes there in which we can make hydrogen. One is steam reforming and one is electrolysis. Okay, so that's pretty much the vocabulary in fuels and heats. Again, I'm just going to pan back here so you can see what I've done. Mine is obviously a bit sloppy because I've got terrible handwriting and I'm not very artistic, but it's all there, essentially, all the vocabulary that you need for this topic. It's a good idea now maybe to read back over your PowerPoint, use your red book, maybe make one yourself. Sure, send it on to me. Let me see what it looks like. And then we'll have a go at a couple of questions. I'm going to do a couple of examples now of the maths part of this question so that you're able to tackle that too. Okay, hope this helps. Bye-bye.